these three guys here. What's the square root? So what is the square root of 16? 4. Why is it 4? You're right, it is 4. But why is that the answer? Not division, it's close because you see that sign, it's not division. You're right. I think I know what you're talking about, but why? Yeah, Marcella?
4 times 4 equals 16.
Yeah, right. 4 times 4 makes 16, right? And when we have pairs, square root just says if you have pairs in there, what is the pair, right? What's the square root of 81? What's the square root of 100? 10, right? You guys have done that before, okay? So now I have different questions to ask. If those are the answers there, what happens when I change it up a little bit? What is the square root of negative 16 then? What's that? I4. What does I mean? Imaginary. How'd you get that?
Oh, no, we did that last year.
Oh, you did it last year. All right. So you did it last year. So some math 2 teachers are doing it this year. Good. Last year. Good. Yeah. Today, your calculator won't help you. Like if you put this, watch, I'll show you. If I put the square root of 16, 4. You guys just said that, right? But what happens if I change it a little bit? My calculator says, nope, can't do it. Undefined means I can't do it. There is no number. There is no number that exists that can do it. And that's true. There is no number. There is no number that exists. There is no number that will make the square root of 16. So what do we do? Because you're going to run into this. Next week, we're going to do our last lesson for this chapter, and you're going to see things like this. And you're going to like, what do I do? There has to be a way of doing something. There has to be a way of solving it, right? There is. And it's like I said earlier. That's where imaginary numbers come from. That's where imaginary numbers come from. They don't exist. They don't exist. But we have to create something that will help us solve these guys, right? We have to create something that will help us solve these. Otherwise, we can't solve them, okay? So we're going to do it this way. So what I'm going to do is I'm going to say, okay, let me separate this. Let me say negative 1 times 16, right? Negative 1 times 81. Let me separate the negative from the number. Because isn't the negative part the one that's causing the problems? The negative part is the one causing my calculator to say, I can't give you an answer. So, without the negative part, I can answer the question. The square root of 16 is 4. The square root of 81 is 9. The square root of 100 is 10. But I still have that negative 1 in here. That's why we created I. So anytime you have a square root in there, throw in an I. Throw in an I. So it's going to be 4I, 9I, and 10I. Okay, that's how we solve it. We say, hey, there's something imaginary in there because it doesn't exist. These numbers don't exist. Ask your calculator. The calculator will not know what it is because it doesn't exist. Calculator's not smart. Your calculator's a tool, right? You have to use it. So you're doing things your calculator can't do. If your calculator was smart, it'd be able to do it, but it can't. Okay? So that's where you have to kind of use your brain to instead. Okay? So let's look at practice down here. Square root of negative 25. Well, the square root of positive 25 is 5. So throw in an I. Square root of 15. Well, the square root of 15 is like 3 point something. So we're going to leave 15 inside, but what I'm going to take out is the negative part. So I'm going to take out a negative. That leaves positive 15. So I put an I in front. Same thing with 31. 31 doesn't have a square root like 1 or 2 or 3 or 10. So I take out the negative and leave in 31. Okay, so anytime we have a negative under the root, we are going to have an I, okay, because it doesn't exist. If you don't believe it doesn't exist, ask your calculator. It'll say, nope, can't do it. Undefined or error. Some calculators even say error. All right, okay, so now that's why we have I. So now what I'm going to do is the patterns part. So go to the back. Okay, so here we go. Now we got patterns now. We got to look for patterns. So we're going to build this. We're going to build the pattern and then see what the pattern is. Okay, so I to the first power is the same thing as square root of negative 1, which is just the same thing as I, right? We said that earlier. Okay, so the first answer we get is just I. I squared. Well, isn't I squared just I times I? Right? Well, what did we say I was? Isn't I the square root of negative 1? So this is the square root of negative 1 times the square root of negative 1. Because each of them represents just the square root of negative 1. So when I multiply the square root of negative 1 times the square root of negative 1, what do you think I'm going to get as an answer? So let's ask. Let's ask the calculator. The calculator will hopefully be able to do this part. So we say square root negative 1 times square root negative 1. Didn't help us. Well, let's use a different number. Let's say the square root of 3 times the square root of 3. So when I ask the calculator, because it doesn't like negatives underneath the root, so let's change it to positive. Let's say I had the square root of 3 times the square root of 3. What's the answer? 3. Okay. Let's try a different one. The square root of 7 times the square root of 7. What are you noticing about the answers? It's the same, right? So what is the square root of, what should this answer be? Negative 1, right? So negative 1. So let's go back to our here. We get negative 1 as an answer. Okay, I squared now. What did I just ask you to do? Okay, next time, 10% off the next test and you can't retake it. I don't know what else to do. I'm trying. I to the third. Isn't I to the third I squared times I? I already know the answer to I squared. The answer to I squared is the orange. So negative 1. And isn't the answer to I just I? So negative 1 times I is just negative I. So I'm highlighting different colors when I get different answers, so we can see the pattern a little easier.
So is 1A always going to be square root of 1?
1A. What'd you say? Say it again.
Sorry, I1, I to the square root of 1, is it always going to be square root negative?
Yeah, so the square root, so I squared is always going to be equal to negative 1. I to the third will always be equal to negative I. I to the first will always be equal to I. Those are always true. Yeah. Okay, so let's do the I to the fourth. Well, what's a way I can break down I to the fourth? I squared, I squared. There's many ways, but I squared is one way. We know the answer. What is the answer to I squared? Yeah, it was the orange one. times the same one. So what do you get when you multiply -1 and -1? +1. Okay, I haven't got that answer yet. All these answers are very similar, but I haven't got quite that answer. Let's go to the I to the 5th. How can I break down 5 using things I know already? Using I to the 1st, I to the 2nd, I to the 3rd, I to the 4th. Second to the 3rd. How about I to the 2nd, I to the 3rd? I already know those answers. I to the 2nd was -1. I to the 3rd is -I. What do I get if I multiply -1 times -I? +I. I've gotten that answer before. So let me give it that color, blue. I to the 6th. Let's break it down using things I know. I to the 4th, I to the 2nd. I to the 4th, the answer was +1. What was the answer for I squared? -1. So what's 1 times -1? I've gotten that answer before. I to the 7th. I to the 3rd and I to the 4th. I to the 3rd is -I. I to the 4th is +1. So what do I get when I multiply -I times 1? -I. I've gotten that answer before. What do you think the answer is going to be for I to the 8th? Let's try. I to the 4th times I to the 4th. 1 times 1. You guys are right. Here's my question now. Here's the big question for today. I'm telling you I'm going to tell you one test question you're going to have when we have the test. Test is coming up because we only have one more new lesson after this. One more new lesson, then we're done with the chapter. I'm going to give you something like this. I to the 73rd. I to the 117th. How can I use my pattern to solve these guys? One way to do it is to make a big list, right? Make a big list. But that list is going to be pretty long to get to I to the 117th. Is there a faster way I can do it? Is there a faster way I can answer those questions using the pattern I just created? That's my question. The answer is there is a pattern. There is a way to do it, right? There is a way. If it's a pattern, I can use that pattern to figure out what's going to come later, right? Because it's I, -1, -I, 1, I, -1, -I, 1. So I to the 9th is going to be -10 will be this, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. You can do it that way to get to here, 117, but I mean, that's going to be a long, and what if you miscount one? Then the whole thing, you have to start over, right? Is there a shorter way of doing this? Is there a shorter way of doing this? Very good. It involves division. It involves division. What would I divide by? What would I divide 73 by or 117 by? You're right. It is division. I'm going to use division. The question is, what would I divide by? Look at the pattern. Yeah, why 4? You're right.
Because if you add 4 to 1 and 5, it's 4. If you add 2 to 6, it's 4. If you add 3 to 7, it's 4.
Yeah, the pattern is 4. Every 4, it repeats itself. Okay, so let's look at dividing by 4. So let's start with I to the 5th. Let's start with I to the 5th. Let me write this down. So 5th power divided by 4. What do I get when I divide 4 into 5? Well, how many times does 4 go into 5? 1 time. Let's go back to 4th grade. 4th grade division. When you first learned 4th grade, when you first learned division, what did the teacher tell you to do with the last number? I got a 1 left. What did the teacher tell you to do? The first thing they told you. Not add a 0. That's the second or third thing they told you to do. What's the very first? No, they didn't tell you to do decimal. That was like the second or third thing. Day 1, what did they tell you to do with the 1? And name it what is it called? A remainder. Remainder 1, right? That's the first way they told you, remainders. And then afterwards they said you can make decimals, fractions, right? So remainder, we're going to go back to that for that day. So remainder. So for that guy, I get a remainder of 1. What if I do divide by 2? Or sorry, divide by 6? I get a remainder of 2, right? What if divide by 7? Get a remainder of 3. What if I divide by 8? I get a remainder of? Why do I get a remainder of 0 there? Because it goes in evenly, right? My question is, which one would 73 fit into? Where would 73 be? Where would 73 be? Mm-hmm. Well, let's see. Goes in once. Goes in 8. So I don't care about the answer. What's the only thing I care about? The remainder. So remainder 1. So which one also had remainder 1? Which one also had remainder 1? 5 did. What was the answer for 5? So what do you think the answer to 73 is going to be? What about 117? Goes in twice. Goes in 9 times. Remainder of 1. So what do you think the answer for 117 is going to be? So when I get a remainder of 1, my answer is always blue. When I get a remainder of 2, what do you think my answer is going to be? Orange. When my answer is, when I get a remainder of 3, what do you think? And can I get a remainder of 4? Why not? Because it goes in evenly. So if it goes in evenly, what do you think I'm going to get? Use that pattern, figure out what these 3 are. What are these 3? What is 21 going to be? I to the 21th power, I to the 48 power, I to the 74 power. What do you think those are going to be? I'll give you a hint. It's either going to be I, -1, -I, or 1. Multiple choice question. So decimals don't work for this kind of division. You need a remainder. So when I divide by 21, that goes in 5 times. I get a remainder of 1. So a remainder of 1 means I. 48. What's my remainder when I do 48? Yeah, I don't get a remainder, right? So if I don't get a remainder, what is my answer going to be? Positive 1. And then 74. I get a remainder of 2. Remainder of 2 means I get negative 1 as the answer. So let's write this pattern down. First thing we're going to do is divide power by 4, right? Divide the power by 4. That's the first thing we're going to do. So we're going to write down what we just did so that when you do these on the test, you don't have to memorize it. You can just say, oh, divide the power by 4, and then one of 4 things is going to happen, right? First thing that could happen is you're going to get a remainder of 1. I could get a remainder of 2. I can get a remainder of 3. I can't get a remainder of 4, so we say no remainder. Okay. So when I divide by 4 and I get a remainder of 1, what is my answer going to be? Yeah, the blue, I, blue. When I divide by 4 and I get a remainder of 2, the answer is going to be negative 1, orange. When I divide by 4 and I get a remainder of 3, my answer is going to be negative I, yellow. And then the last one, I don't get any remainder. It goes in evenly. I get an answer of positive 1. Okay, so use your newfound rule to do this one. I to the, let's say 99. What would I to the 99 power be? I to the 99th power. I'll give you a hint. It's either A, B, C, or D. Blue, orange, yellow, or green. For calculators, unless they do remainders, which I've never seen a calculator that does remainders, won't really help you too much. You got to do this part by hand. It's not hard, but you just got to know what the remainder. So what is the remainder when you divide by 4? 3. So you get negative I. Okay. That's the pattern. That's the pattern. So when you get something crazy like that, just divide it by 4. Which one does it fall under? Whatever one it falls under, that's the answer. Okay? Because it repeats every 4 times. All right. That was the hard part about today, the pattern part. The rest of it's pretty relatively regular for you guys. It's nothing crazy. So what do you think? If you could guess, what do you think I would do here for A? Distribute, right? What do I distribute to get rid of the parentheses? Isn't there ones in front of the parentheses? We just distribute whatever's in front of the parentheses. Distribute the 1 to get rid of the parentheses. And then what do you think I'm going to do? Combine like terms. Yep, that's it. 5. Here's the only thing with this. When you write this answer, the imaginary part has to come second. Imaginary second. Imaginary part second. Has to come second. That's just the way it is. Because it's imaginary, it doesn't go first. So if I were to put 8i plus 5 into Delta Math, it would say you're wrong. Like, why am I wrong? I did it right. Because the imaginary part has to come second. Okay? Has to come second to the real. Because it's imaginary. It's not real. Okay? Okay, so here we go. B. What do I have to distribute to get rid of these parentheses? Yep. Negative or negative 1. Combine like terms. So we get negative 4 plus 2i. Remember, the I has to come second. It's a second-class citizen. It's got to come second. Don't feel like you're discriminating against the imaginary. It's what we do. Okay? It doesn't exist. It's not real. So it has to come second. Okay? Don't feel bad for it because that's just what we do. Okay? All right, do C. Do letter C. It's a multiplication. You're multiplying the first parentheses times the second parentheses, but they're binomials. There's 2 parts to it. So we're going to use something that'll look familiar. We're going to use a table. We've used the table before, but we're going to use it a little differently than we've used it before. We're used to starting out on the inside, putting things on the inside and then figuring out what's on the outside. We're going to do the opposite. We're going to do the opposite. So the first one is 3 plus I. That's going to go on top. The second one is 1 plus 2i. That's going to go on the side. What we have to figure out is what was the stuff that went inside. How do we figure out the stuff? We use multiplication. 3 times 1 makes 3. I times 1 makes 1i. Three times 2i makes 6i. And then I times 2i makes 2i to the second power. Combine like terms. These two guys are both have just a regular I. So we have 3 plus 7i plus 2i to the second power. Here's the thing about these. Remember I said that i's have to come second? They do have to come second, and I do have them second. But another rule against i's is that we can't finish with anything other than I. So I squared, I to the third, I to the fourth, I to the fifth. If I get those, I have to change it. Change it to what? Well, what is I squared equal to? Look on your chart. What is I squared equal to? So change it to -1. So this is what I'm going to do. I'm going to rewrite it. Instead of I squared, I'm going to put a -1 because they're equal. They're actually the same thing. So I get 3 plus 7i, and this is -2 because 2 times -1 is -2. Now combine like terms again. And I get +1 plus 7i. No more I squareds. I's are okay. They just come second. I squareds, I to the third, I to the fourth. We got to change it. Okay. All right. Okay. Letter E. Similar thing as the last one. The only difference is I have a 6 in front. Well, guess what I'm going to do with the 6 before I do my multiplication? Distribute. Yeah, the 6 you're just going to distribute. Distribute the 6 only to the first one because I only have 1 6, so I can only distribute it to the first set. So I get -42 plus 36i. The second one stays the same since I only had 1 6 to distribute. Now it looks like the problem I just did, just bigger numbers. So we go over here. -42, positive 36i, -4, positive 2i. Multiply. -42 times -4 is going to be positive 168. Positive 36i and -4, when I multiply those, I'm going to get negative 144i. -42 times positive 2i, negative 84i. The last one, positive 36 and positive 2i, I get 72 I to the second power. Combine like terms. These two guys I can combine since they just have an I. So when I combine them, I add them. You get 228. Can't finish with an I squared. So now we have to plug in -1. When you do that, all it does is change the sign. So from positive 72 to negative 72. So when we combine those, we get 96. So positive 96 minus 228i. Done. F, and then we're done. I'm not going to give you any more. After F, we're done. I'm not going to give you any more to do. I'll let you tape after that. Okay? f is squared. What does squared mean? Times itself. So I'm just going to rewrite it a different way. That makes a little more sense. Negative 12 plus 2i times negative 12 plus 2i. That's what it is, right? Well, we're going to do what we just did, make a table. Make a table and multiply. Negative 12, positive 2i. Negative 12, positive 2i. And we just multiply. Negative 12 times negative 12 makes a positive 144. Two I times negative 12 makes a negative 24i. Negative 12 times positive 2i makes another negative 24i. You can do this last part, and some people do this last part in their head. It's 2i times 2i, which makes 4i squared, right? But we can't have I squareds. So it's 4i to the second power. What is that going to end up becoming? Negative 4, yeah. So if you can do that in your head, do it in your head. If not, write I squared. These two guys can be combined since they both are like terms. So I get 144 minus 48i plus 4i squared. I squared, change that to negative 1. That's going to make positive 4 into negative 4. Oops, forgot the i's. $140 minus 48i. Okay. Just remember, don't finish with I squareds. Don't finish with I squareds because it'll say you are wrong. Okay? So put i's second and don't finish with I squared. Let's see, where's my... Okay. I's always come second, and then remember to change I squared to negative 1. Remember those two things. Those are the things that are sometimes you forget.